Hello guys, and welcome back to this channel. In today's video we are going to learn how to find the limit of a function. The limit of a function f of x such that x approaches the value e is written as the limit of f of x as x approaches the value e, and this limit is obtained by replacing x by e in the function so that the limit of f of x as x approaches e is equal to f of e. So for example, if you are asked to find the limit of a function f of x as x approaches the value 3, given that f of x is equal to x plus 4. Now to find the limit of this function, we are going to directly substitute the value of 3 into the function. So we are going to have the limit of f of x as x approaches 3 is equal to the limit of, now we have f of x to be x plus 4 as x approaches 3. Now we are going to substitute the value that x is approaching, which is 3, into the function, and then we are going to do away with the limit. So we have 3 plus 4, and then we have our limiting value to be 7. So this is one way of finding the limit of a function, that is directly substituting the value that x is approaching into the function to get the limiting value. So now let's solve some examples on that. So for the first example, let's find the limit of the function 4x squared minus 12x plus 4 as x approaches 4. So to find the limiting value, we are going to substitute the value of 4 into this function. So we are going to have 4 into bracket 4 squared minus 12 into bracket 4 plus 4. Now 4 squared is 16, so 16 times 4 is 64. So we have 64 minus 12 times 4 is 48, and then plus 4. Now 64 minus 48 is 16, and then 16 plus 4 is 20. So we have our limiting value to be 20. Let's solve our second example. Let's find the limit of the function x squared minus 3x plus 5 as x approaches 2. So like we did for example 1, we are going to substitute the value of 2 into this function. So we have 2 squared minus 3 into bracket 2 plus 5. 2 squared is 4, so we have 4 minus 3 times 2 is 6, and then we have plus 5. Now 4 minus 6 is negative 2, and then negative 2 plus 5 is 3. So we have our limiting value to be 3. Now let's look at how to find the limit of rational functions. Now a function f of x is said to be rational if f of x is equal to g of x divided by h of x such that h of x is not equal to 0. Now the limit as x approaches e is given by lim f of x as x approaches e is equal to f of e, and that's also equal to g of e divided by h of e. Now if the values of g of e and h of e are both 0 or infinity, then we need to manipulate the rational function or reduce the rational function to its simplest form before we plug in the value x is approaching in order to find the limiting value. So to better understand this, let's try to find the limit of a function f of x, given that f of x is equal to x squared minus 4 divided by x minus 2 as x approaches 2. So we have the limit of f of x as x approaches 2 to be equal to lim. Now f of x is x squared minus 4 divided by x minus 2. So we have x squared minus 4 divided by x minus 2 as x approaches 2. So from what we learned, we are going to substitute the value of 2 into this function, and then we are going to do away with the limit. So we have 2 squared minus 4 divided by 2 minus 2. Now 2 squared is 4, so we have 4 minus 4, and then we have 2 minus 2. Now 4 minus 4 is 0, and then 2 minus 2 is also 0. Now 0 over 0 is undefined. We don't know what value it is, hence we need to use a different approach. So whenever you want to find the limit of a rational function, and then you get your answer to be either 0 over 0 or infinity over infinity, it means that this is undefined, and then you need to use a different approach to solve the limit. So since we have 0 over 0, we are going to use an alternative method to solve the limit. This is where we are going to manipulate the rational function, or to reduce the rational function to its simplest form, and then we plug in the value that x is approaching to find the limiting value. So that's what you are going to do. So the function given was f of x equals x squared minus 4 divided by x minus 2 as x approaches 2. So we are going to find the limit of f of x using an alternative approach. So we have lim f of x as x approaches 2 to be lim x squared minus 4 divided by x minus 2 as x approaches 2. Now x squared minus 4 is the same as x minus 2 x plus 2. So we have x minus 2 x plus 2 divided by x minus 2, and then we have the limit as x approaches 2. Now we can cancel out x minus 2 and then x minus 2. So the limit reduces to x plus 2 as x approaches 2. Now we are going to plug in the value of 2 in the function. So we have 2 plus 2, and that is equal to 4. So you can confirm your answer by substituting a value that is closer to 2 into the function, that is the original function. So f of x is equal to x squared minus 4 divided by x minus 2. So let's take x to be 2.01. Now if we pick any value less than 2, we are going to get a negative answer. So we want to pick a value that is greater than 2. So we have x equals 2.01. Now let's plug in this value into this function. So we have f of 2.01 equals 2.01 squared minus 4 divided by 2.01 minus 2. Now 2.01 squared minus 4 will give us 0.0401 divided by 2.01 minus 2 is 0.01. So this is going to give us 4.01. So this technique works for any limit, so long as you plug in a value that is closer to what x is approaching, so that if the limit exists, then it's going to converge around a certain value. Now let's solve some more examples. So for example 1, we are going to find the limit of the function 8x plus 9x squared divided by x into bracket x squared minus 9 as x approaches 0. So first of all, let's substitute the value of 0 into this function. So that's going to be 8 into bracket 0 plus 9 into bracket 0 squared divided by 0 multiplying 0 squared minus 9. Now 8 times 0 is 0, 9 times 0 squared is 0, and then 0 multiplying everything here is also 0. So we have 0 divided by 0, which is undefined. So since this is undefined, we can't use this approach to find the limit. We need to use the alternative approach. So what we are going to do instead is to factor out x so that we can cancel out and then we can find the limiting value. So we have the limit as x approaches 0. We have 8x plus 9x squared divided by x into brackets x squared minus 9. So here we are going to factor out x. So that is going to be the limit as x approaches 0 of, now we have x into brackets. Now 8x divided by x is 8. And then 9x squared divided by x is 9x. We already have x here, so let's not touch it. And then inside the brackets we have x squared minus 9. Now we can cancel out x and then x. So the limit reduces to the limit as x approaches 0 of 8 plus 9x divided by x squared minus 9. Now we can plug in the value 0 into this function. So let's do that. So we are going to have 8 plus 9 times 0 divided by 0 squared minus 9. Now 9 times 0 is 0, so we have 8 plus 0, which is 8. And then we have 0 squared to be 0, and then 0 minus 9 is negative 9. So we have our limiting value to be negative 8 over 9. So let's take the second example. So for example 2, let's find the limit of the function 2x cubed minus 3x squared plus 4x divided by 5x cubed plus 2x squared minus 3x as x approaches 0. Now for this function, if you put in the value 0, we are going to get the denominator to be 0, which means that we are going to get the limit to be undefined. So we are going to manipulate this rational function. Now what we are going to do is we are going to factor out x. So we have the limit as x approaches 0 of x, and then we have 2x squared minus 3x plus 4 divided by x into bracket 5x squared plus 2x minus 3. Now let's cancel out x. So the limit reduces to 2x squared minus 3x plus 4 divided by 5x squared plus 2x minus 3. Now let's put in the value 0. So we are going to have 2 times 0 squared minus 3 times 0 plus 4 divided by 5 times 0 squared plus 2 times 0 minus 3. Now 2 times 0 squared is 0, and then negative 3 times 0 is 0, and then we have plus 4. Now 5 times 0 squared is 0, 2 times 0 is 0, and then we have negative 3. So we have our limiting value to be negative 4 over 3. So for example 3, let's find the limit of 3x minus 4 times 2x plus 3 minus 5x minus 2 times x plus 6, all divided by x into bracket x squared minus 9 as x approaches 0. Now let's multiply the terms at the numerator. So we have the limit as x approaches 0. Now let's multiply this and then this. So we have 3x times 2x to be 6x squared. We have 3x times 3, which is 9x. We have negative 4 times 2x, which is negative 8x. And then negative 4 times 3, we have negative 12. Minus, now we have 5x times x, which is 5x squared. we have 5x times 6, which is 30x. We have negative 2 times x, which is negative 2x. And then we have negative 2 times 6, which is negative 12. And then divided by x into bracket x squared minus 9. Now we have the limit as x approaches 0. So let's simplify. We have 6x squared, 9x minus 8x is 1x minus 12. Now let's multiply negative 1 across. So we have negative 5x squared, we have negative 30x, we have plus 2x, and then plus 12 divided by x into bracket x squared minus 9. So we are still going to simplify. So we have the limit as x approaches 0. Now 6x squared minus 5x squared is x squared. We have x plus 2x minus 30x, and that's going to give us negative 27x. We have negative 12 plus 12, which is 0. So we have that divided by x into bracket x squared minus 9. Now let's factor out x from the numerator. So we have the limit as x approaches 0 of x into bracket x minus 27 divided by x into bracket x squared minus 9. So x cancels out x, and then we have the limit as x approaches 0 of x minus 27 divided by x squared minus 9. So let's substitute 0 into this function. So we have 0 minus 27 divided by 0 squared minus 9. So we have negative 27 divided by negative 9, which is equal to 3. So the limiting value is equal to 3. So for example 4, we are going to find the limit of the function x cubed minus 1 over x minus 1 as x approaches 1. Now what we are going to do is we are going to expand the numerator. We are going to do that using the formula a cubed minus b cubed equals a minus b in a bracket multiplying a squared plus ab plus b squared. So since we have x cubed minus 1 cubed, we are going to have x minus 1 and then x squared plus 1x plus 1 squared. So that is x minus 1 and then x squared plus x plus 1, because a is equal to x and then b is equal to 1. So that is what we have here. So let's substitute the whole of this in place of x cubed minus 1. So we have the limit as x approaches 1 of x minus 1 times x squared plus x plus 1 all over x minus 1. So x minus 1 cancels out x minus 1, and the limit reduces to the limit as x approaches 1 of x squared plus x plus 1. Now we are going to substitute 1 into the function. So we have 1 squared plus 1 plus 1, and that's equal to 3. Now let's solve our last example. So for the last example, we are going to find the limit of the function 16 minus x divided by 4 minus the square root of x as x approaches 16. Now because of the square root, we are going to multiply top and bottom by the conjugate of the denominator. So we have the limit as x approaches 16 of 16 minus x over 4 minus root x multiplying 4 plus root x over 4 plus root x. Now we are going to multiply across. So we have the limit as x approaches 16. Now 16 times 4 is 64. 16 times root x is 16 root x. Negative x times 4 is negative 4x. And then negative 4 times root x is negative x root x. Divided by, we have 4 times 4 is 16. 4 times root x is 4 root x. Negative root x times 4 is negative 4 root x. And then negative root x times root x is negative x. Because root x times root x is equal to root x squared. The square cancels the square root, so we have x. Now because this is negative root x, we have negative x. So now let's simplify. We have the limit as x approaches 16. So we can factor out some of the terms. Now let's consider 64 and then 16 root x. So we can factor out 16 to have 4 plus root x. And then minus x into bracket 4 plus root x. Divided by, now 4 root x minus 4 root x is 0, so we are left with 16 and then minus x, so that is 16 minus x. Now since we have 4 plus root x and then 4 plus root x, we can factor out 4 plus root x. So we have the limit as x approaches 16, then we factor out 4 plus root x, so that is 4 plus root x on the outside, and then we have 16 minus x inside the bracket divided by 16 minus x. So this cancels out this, and the limit reduces to the limit as x approaches 16 of 4 plus root x. Now we are going to substitute the value 16 into this function, and then we have 4 plus the square root of 16, which is equal to 4 plus 4, and then we have our limiting value to be 8. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.